Hello, and welcome to another SolidWorks tutorial. In this video, we will work with a few more tools in the assembly environment. First, we will design a part in the part environment on the top plane. We create a sketch and draw a center rectangle. We set its dimensions to 300 millimeters by 20 millimeters. Then we also give the part some thickness. Now we want to create several threaded holes on this face using Hole Wizard. In the Type tab, we choose the standard and set the hole size and pitch. For example, we select M16 with a 1.5 millimeter pitch. We set the hole to go through all, and the thread to continue fully as well. Then in Positions, we select the face and place the first holes. Next, with Linear Sketch Pattern, we create multiple holes on this surface. We set the spacing between them to 50 millimeters. And we set the number of instances to 5. Then in the other direction, we create another row of holes. Here again the spacing is 50 millimeters, and we reverse the direction. In this direction we use 4 instances, and in the other we keep 5. Then click OK to create the holes, and open Options to display the threads. In Document Properties under Detailing, enable Shaded Cosmetic Threads. Now the thread display is visible. Next, we will model a bolt and nut. We create a new part, and on the top plane we start another sketch. Then we draw a circle with a diameter of 16 millimeters. Next, we extrude it by 100 millimeters and start another sketch. In that sketch, we draw another circle with a diameter of 18 millimeters. This second circle will form the head section. Then we extrude it by 12 millimeters and start a sketch on this face. Now we prepare the profile for the cut. Here we draw a hexagon on the face. We set its size to 6 millimeters and make it horizontal. Then we use extruded cut with a depth of 6 millimeters. That creates the hex socket cut. Now let us check the dimensions. This shaft is 16 millimeters. And this head section is 18 millimeters. Next, we add the thread. We can do that with Cosmetic Thread from the Annotations tab. Here we choose the M16 by 1.5 thread size. Then we select this cylindrical edge for the thread feature. We can set the end condition to up to next, but the pitch changed here. So I set the pitch back to 1.5 and click OK. To see the thread clearly, go to Document Properties and then Detailing. Enable the display option. Yes, this is the thread we wanted. Now let us verify the part. It is correctly defined as M16 by 1.5. Next, we want to bring this part into the assembly environment. From File, we choose Make Assembly from Part, but first it asks us to save. So we save this part first, and we also save the plate part we created earlier. After that, we can insert the part into the assembly. We place it directly at the origin point. Then we hide the origin and save this part file as part 7. After that, we return to the assembly environment again. Now we insert that 7th part into the assembly as well. First, we want to assemble this bolt into one of these holes. We can click the surfaces directly or open the Mate tool first. Then we select this cylindrical face and the hole. That gives us a concentric mate, so both axes become aligned. For the second mate, we select this face and the matching surface here. Then we apply a coincident mate so the bolt seats properly. Now the bolt is assembled, but it can still rotate freely. If we want to lock its rotation, we need one more mate. For example, we can set one face parallel to another face. So we open Mate again and select this face first. Then select the other reference face and choose Parallel. Now both references are aligned, and the bolt no longer rotates. Next, we can use linear component pattern in this assembly. With it, we can place the repeated bolts across the plate. To do that, activate the tool, and in Components to Pattern select the bolt. You can select the bolt directly here, or choose part 7 from the tree. Then for Direction 1, select this reference edge or direction. The spacing between holes was 50 millimeters in this direction. And the number of instances here should be 5, with the direction reversed. That way, the pattern bolts sit exactly on the holes. For Direction 2, select this reference and set the count to 4. Now the full pattern is assembled correctly, so click OK. You can see how easily linear pattern assembles many bolts at once. The next tool we want to work with is another assembly command. That tool is Smart Fasteners. Before using it, let us delete this part from the assembly. When you create a threaded hole, this tool can recognize it automatically. Then it suggests a matching bolt and nut for that hole. But if you click it now, you may get an error message first. That is because you need to activate the SolidWorks Toolbox. In the Design library, you can find the Toolbox folder here. If you expand it, you will see several standards available. For example, you have ANSI along with other standard systems. You also have ISO and DAN, and you can choose whichever standard you need. Then SolidWorks shows many ready-made components from that standard. So we do not model every standard part manually. We use toolbox items. For example, we usually do not model gears from scratch. Instead, we can use the toolbox gears and adjust their properties. Now that the toolbox is active, we can use this assembly tool. So we click the Smart Fasteners command here. Click OK, and in the selection box, choose one of these threaded holes. Then click Add, and now you can define the fastener settings. For example, you can set the size, and it is already on M16. That is the size we want. Here we also set the length to 100 millimeters. Click OK. Then you can also define the thread length. We want the thread length to be 100 millimeters as well. This section controls the display style, such as showing it as cosmetic. Set the options you want, and after that click OK. Then SolidWorks creates all of those fasteners automatically. So this tool is also very useful for assembly work. The next tool we want to try is Copy with Mates. First, let us delete these fasteners from the assembly. Now let us insert part 7 again and place it here. We assemble it again by making this face coincident with this face. Then we choose Parallel and make this edge parallel to this reference. Click OK. Now we can work with Copy with Mates. Of course, linear pattern is very useful in cases like this. You already saw how quickly we pattern the bolts in both directions. But Copy with Mates is another useful option you can use. To activate it, first select the component you want to copy. For example, select this part here and then click Next. Now SolidWorks shows the mates used for this component. You need to redefine those same mate references for the new copy. For example, the first mate here was the concentric mate. So for the new copy, we click the next hole to apply that relation. The next mate was a coincident mate with this face. SolidWorks even highlights the reference type with a matching color. So we select this face to recreate that second mate. We also had a parallel mate based on this edge, so we select that too. After selecting all the mate references, click OK and the part assembles. Now we can create another copy as well, and this time even faster. Select this face, then this hole, and the new copy is placed. Click OK again. You can repeat the same process very easily. So yes, this tool is also easy to use in the right situation. Still, for a geometry like this, linear pattern is usually the better choice. But in some other cases, Copy with Mates can be the better tool. That is all for today's lesson. I hope you found it useful. Goodbye.